We ready to go? Ready to go. All right, we're going to start graphing these on the polar grid. First one, graph r equals 5. Now, if you remember, I know it's been a while because it was probably the first day of this unit. When we graphed a polar coordinate, it was always r comma theta. So for instance, if I had 2 comma pi over 6 and I had you guys graph that, just take a look at my graph real quick. 2 pi over 6, I'd go to pi over 6, and then I'd count out 2 units, and that would be my point. All right? You'll notice something about this first graph, though, is you got an r value, but what's missing? Yeah, theta. So what that means is if you're just given the r value, that's for all the thetas. All right, that's for all angles we're going to graph r equals 5. So at 0, and you guys will hopefully catch on pretty quick here. So at 0, it's going to be r equals 5. So count out 5, everyone, and graph. 1, 2, 3, 4, 5. Do I have that in the right spot? I can't see if there's right before the, or is it at the end? There should be a little circle around there. That would be 1, 2, 3, 4, 5. And for every angle of theta, it's going to be 5. So you go to pi over 12. Yep. 5. I'll wait so I don't interrupt any conversations because I don't want to be the rude one. I forgot we're seniors, so I should just let everything fly. If you keep graphing 5, you'll notice, what are you going to end up forming? You're going to end up forming a circle. Yeah, and I'll show you why that makes total sense in a second, that you would end up with a circle on here. Yep, so go ahead, connect your points, and draw in your first polar graph. And they're all not going to be like that. But so if you just have an r value, no theta, every theta is 5. We good there? Why does this make sense that it's a circle? I might be asking a lot here. Go back to yesterday's quiz. If I had you convert that into rectangular equation, what would you do? If I had you convert that into rectangular, r equals 5. I would square both sides and get what? R squared equals 25. What was your substitution for r squared? And we talked, what's x squared plus y squared? A circle. Yep. All right, so that makes sense. Any issues yet when it's just an r value, no theta? All right, well, what about the r value is negative? Anybody remember how we handled that? So let's say I'm going to plot it at 0. So instead of going 1, 2, 3, I actually go on the opposite ray and go 1, 2, 3. But what's still going to happen? I'm still going to go, every time I go opposite, I'm still going to hit every 3 units of a radius. So, yep. So you're okay before I put a theta in because they're not going to be all circles, as you're going to find out now. Any issues here? We ready to go with the theta now? Lucky for you guys, I'll always set up the table for you. All right, I'll always set up the table for you. I will give you the theta. You guys are in charge of finding what the r value is. Okay? Here's the thing that's going to drive me nuts. I know already. Decide what mode you want to be in. Are you going to stick with radian mode, or are you going to convert it to degrees in your calculator? Just figure out right now, make a decision, what mode are you going to stay in? Are you going to go to radians, or are you going to go to degrees? All right, so make that decision before you start typing into your calculator. We ready? So at 0, theta equals 0. We're graphing 4 cosine theta. So R will be 4 times the cosine of 0. So everyone, go ahead into your calculators right now, 4 cosine 0, and let me know what that R value is going to be. 4 cosine 0. And what do we end up getting? 4 cosine 0, what's your R value? Should be 4. So that means the first point I'm going to graph is not 0, 4. Not 0, 4. What is it? It's R theta. 4, 0. All right. Let's go ahead and graph that now. 4, 0. Well, actually, let me see you graph it. 4, 0. So at 0 degrees, we're graphing 4. 4 units out. We're going to go baby steps with this. So 4 units out. Everyone ready now? Pi over 6. So 4 times the cosine of pi over 6. Now, put it in radians if you're going to plug in pi over 6 in your calculator, or if you're in degrees, what's pi over 6? 30 degrees. Guys, please make a darn decision. Okay? Make a decision. Are you going to put pi over 6? Make sure it's in radian mode. If you're going to put 30, make sure it's in degree mode. And after you plug that in, about what? We go about nearest tenth here. Nearest tenth. 1 point. Oh, I'm on the wrong one. Sorry, you're right. Sorry, 3.5. If you're not getting it, please stop now and ask. Yes, Matt. 4 times the cosine of either pi over 6 if you're in radian mode, or 30 if you're in degree mode. So 4 cosine, and then I don't know what you're plugging in from there, depending on what mode your calculator's in. Everyone all right with 3.5? So what point am I going to graph? 3.5, comma, pi over 6. Go ahead on your graph. 3.5, pi over 6. And the way we graph these on the polar, you connect them as we go. They are connected in order. All right, they're going to be connected in order. Next, 4 times the cosine of pi over 3, which is, if you're in degrees, was what? Pi over 3? 60 degrees. Yep, if you're in degree mode. So 4 times the cosine is 60. That should be a whole number. 2. So we're going to graph 2 comma pi over 3. We connect them as we go. Any issues? Sorry I'm going so slow, but I want to make sure we got this. Now, when you guys do this on your own, if you rather fill in the table on your own and then graph, that's fine. Or if you want to do it like we're doing, find a coordinate graph, find a coordinate graph. All right, pi over 2. Pi over 2, if you're in degrees, it would be what? 90 degrees. You should get another whole number here. Your R value. Yep. So we're going 0, 90, or pi over 2, excuse me. So we're back at the beginning, the origin, the pole as it's called. Back at the pole. All right, let's keep this show on going. 2 pi over 3. If you guys are in degree mode, remember, what's pi over 3? 60 times 2, $120. There should be a negative number, I hope. What are we getting out here? -2. All right, hey, be careful now. Guys, be careful. You got a negative R value. -2, 2 pi over 3. Ready? Hey, tell me, because here's 2 pi over 3, but I'm not going to graph it here. Why not? If it's negative, I go on the opposite side. All right, so if it's negative, 2 pi over 3, right there. Please remember that. If it's negative, you go on the opposite side. I think that looks opposite to me. I don't know. I don't have. Should be at 5 pi over 3. Yeah. All right, we're almost home here. 5 pi over 6. What's that? 30 times 5? 150 in degrees. What do you got? Negative 3.5. Yep. So 5 pi over 6. Where's 5 pi over 6? There it is. But it's negative, so I'm going in the opposite direction. Where am I going to here? 7 pi over 4. So 1, 2, 3.5. All right. I missed one.
Why you go to 7 pi?
What's that?
Why you put it
5.
7 pi? Wait,
All right. Hold on. Okay. So it's 5. It was 5 pi over 6. So go to 11 pi over 6, right? Okay. I just can't even. I can't hardly see up here. 1, 2, 3.5. Better. There you go. And then for pi, what are you getting for pi? Pi is negative 4. And what do you notice now? We've already graphed it, right? So let's keep going. Yep. Seven pi over 6. Let me know what value you get out there. What do we end up with? Negative 3.5, right? So 7 pi over 6, it's negative. I go here, and what do you notice again? What do you notice? We've already graphed it, right? Okay, let's just keep going to finish this up. 3 pi over 2. Be careful here. Be careful. 3 pi over 2. What are you getting for your R value of 3 pi over 2? Should be getting 0, right? 0? Okay, hold on, though. We just don't keep going around, though, do we? Because didn't we? Actually, we do, don't we? No, we just graphed 3.5, right? So where's it got to go to now? Is everyone, hey, 3.5. That was this point right here we just graphed. We all in agreement. Okay, where's it going now? 0, 3 pi over 2. So where's it going to go back to? It's going to go back to the origin, right? Everyone see that? Yeah. Coming back. No? What am I missing? For 3 pi over 2, which is 270? 3 pi over 2? Pi over 2 is 90. 90 times 3 would be 270. So you're doing 4 times the cosine of 270. We good? Okay, let's go. Last one. 5 pi over 3. Five pi over 3. 2. 2 comma 5 pi over 3. Let's see where we are because I got to graph it from the pole now. 5 pi over 3 going to 2. So 1, 2. So I'm going to come it back right there. Yep, there it is. Same line. Okay, so it's not a circle. I shouldn't see a circle. I should see this right here because I went from negative 3.5 for r to 0. All right. And here's why it's not a complete circle. We're not done yet. No, we're not shutting it down yet. Because this wasn't the greatest thing on yesterday's quiz. Help me convert that into rectangular. Now, I'm not squaring both sides because that's going to be cruddy on this side. How else can I get an r squared instead of squaring? Multiply both sides by r, so r squared equals what on this side? 4r cosine theta. X squared plus y squared equals 4x. So it's not really a circle by itself with a little more. All right, that's where that comes from. All right, so it's not a full, total, genuine circle because I have that 4x there, unlike number 1. All right, questions? Whew. All right, we'll see how Monday goes.